class. Today I'm going to teach you guys about medians and altitudes. In the first picture that we have, AC is a median. Some of the characteristics of a median are that it hits at the midpoint of the side to which it is drawn. We could also say that it bisects the opposite side. But really, to be a median, the segment has to start at the vertex of a triangle and then be drawn to the midpoint of the opposite side. We have two new theorems relating to medians as well. The first one is the straightforward way. If a segment is a median, then it hits at the midpoint of the side to which it is drawn. If we reverse this, we would start with the then part, but here's what it would look like. If a segment divides the side to which it is drawn into two congruent parts, then it is a median. It's important to talk about, too, that we can draw a median from any vertex of a triangle. So in your picture, I've drawn in the median from A to C, but I could also draw in a median from D that hits AB at its midpoint, or I could draw a median from vertex B that hits AD at its midpoint. If I drew something like this that just hits C to AB, that is not a median. Because again, a median has to start at a vertex. The next shape, or the next figure that we should talk about, is an altitude. So in the next picture, AD is an altitude because it forms a right angle with the side to which it is drawn. Again, an altitude has to start at the vertex of a triangle and be drawn to the opposite side. We have two theorems relating to altitudes that we can use in our proofs as well. Again, the first one is the straightforward one. If a segment is an altitude, then it forms right angles with the side to which it is drawn. Or we can reverse it and say if a segment forms right angles, with the side to which it is drawn, then it is an altitude. Just like with the median, we can draw an altitude from any vertex to any side. As long as we're forming a right angle with the side that we're drawing it to, it's an altitude. We do have a special case for an altitude in an obtuse triangle. In an obtuse triangle, the altitude actually has to fall on the outside of the triangle. So that is possible as well, to have an altitude fall on the outside of a triangle. It usually only happens if the angle is obtuse though. We will see how to use these new theorems in our proofs in just a couple minutes. Segment. All right, now we're going to move on to something else that might be helpful as you guys are doing your proofs. If you look at the picture, given circle C, and given that BD is perpendicular to AC, so go ahead and mark that, we want to prove that triangle ABC is congruent to triangle ADC. But if you notice, we don't even have a triangle yet. So in this case, it might be helpful to draw in lines in our picture. You are actually going to be allowed to do this. So for this first one, we would want to draw in segment AD and segment AB. And those lines are called, when you have to draw them in yourself, those are called auxiliary lines. Basically, they're lines that you can draw in to help make your proof easier. If you look at the next picture, we've got, given that D is the midpoint of CB and AC is congruent to AB, we're trying to prove triangle ACD is congruent to triangle ABD. But again, we don't even have a triangle until we first drew in segment AD. When you do this in a proof, you need to state that you're going to draw in a line. So if you were doing your proof and you had whatever going on, maybe you had some givens, and then you wanted to draw something, you would actually make a statement that says draw segment AD, and then for your reason, you would say 2 points determine a line. We'll see examples of this as you go through notes and homework as well. All right, so let's go ahead and try a proof. Let's see what this is going to look like. So just like always, we're going to start with our givens. So step 1, I've got segment CA is congruent to segment BA. I'm going to mark that on my picture. And we also know that angle CAD is congruent to angle BAD. Which are these angles at the top? So if I go ahead and write down both 1 and 2 were my givens. If you notice at the heading for this note sheet, it said that these were steps beyond CPCTC. So just like we've been doing all chapter, we're probably going to need to prove triangles congruent first. So the one thing that's jumping out at me is that I could say that AD is reflexive. So I'm going to go ahead and say AD is congruent to segment AD by the reflexive property. And now I have enough information to get congruent triangles. So I'll go ahead and say triangle CAD is congruent to triangle BAD. Again, make sure you're paying attention to corresponding parts. And that would be by side angle side from steps 1, 2, and 3. Now I'm going to look, I'm trying to prove that AD is the median to CB. So hopefully you're remembering from the first page that a median hits at the midpoint of the side to which it is drawn. So before I can say that I have a median, I need to show that CD is congruent to DB, which I know because of CPCTC. So to this point, we've done proofs like this before. CD is congruent to DB, CPCTC. And now, this is the new part. Now I'm ready to say that segment AD is the median to segment CB. And the reason is going to be if a segment hits at the midpoint of the side to which it is drawn, then it is a median. know that these are kind of longer reasons, and unfortunately there's no real shortcut, but just do the best you can to state it as close to that as you can. Our given circle C. Okay, so let's go ahead and try this next proof here. For this one, we are given circle C, and we also know that xy is congruent to zy. So let's go ahead and write that in our proof. Now, the next thing that's jumping out at me is that we need to draw in segment YC. This is going to give us two triangles that we should be able to prove congruent, and it should help us get angle x congruent to angle z. So in my next statement, I'm going to state draw segment YC, and for the reason, we're going to put 2 points determine a line. That's a postulate that we're not going to prove. We're just going to assume to be true. So 2 points determine a line. Now I'm going to look back at my picture and figure out, okay, I know that xy is congruent to zy. And I know that I have YC drawn in. Now I haven't really used my first given yet, which is that I have a circle. So I think the next thing I'm going to say is that segment XC is congruent to segment CZ because all radii of a circle are congruent. Don't forget the of a circle part. And then the part that I just drew in, segment YZ, that's a reflexive segment. So I'll go ahead and say that step 5, segment YC is congruent to segment YC, reflexive. And now I have enough to say that the two triangles are congruent. So I'll go ahead and name them. Triangle YCX is congruent to triangle YCZ because of side, side, side. And in my proof, that was steps 2, 4, and 5. After we prove triangles congruent, we usually need to say CP/CTC. So if I'm looking at what I'm trying to prove, I'm trying to prove angle X is congruent to angle Z. Those are parts of my congruent triangles. So I'm ready to say angle X is congruent to angle Z just by CP/CTC. I'm done. Okay, so let's go ahead and give this last proof a try. This one I was nice and just gave you a little fill in the blank here. So the first statement says that ray AC bisects angle DAB. What do you guys know about if a ray bisects an angle? Hopefully you're saying two congruent angles. If you are, you would be right. So if we're bisecting angle DAB, the two angles that are congruent would be angle DAC and angle BAC. So I'm going to go ahead and put that for my statement. Angle DAC is congruent to angle BAC. And they've already written the reason for you. If a ray bisects an angle, then it divides it into two congruent angles. Okay, then moving on to the next given. The next given says segment AC is an altitude of triangle ADB. All right, think about what you know about an altitude. We just learned that an altitude forms right angles with the side to which it is drawn. So we're going to have a right angle for angle ACD. And I'm going to make these separate steps. And angle ACB. So I'm going to say angle ACD is a right angle, as well as angle ACB is a right angle. Okay, now if you look at the reason, this one is not completely filled out for us, so we need to say if a segment is an altitude, because that's what we knew in the step before, then it forms right angles with the side to which it is drawn. Again, it's a little bit longer reason than we've used to lately. We've been a little bit spoiled, but you can handle it. All right, the next step is just blank. All right, well, we might have to come back to that, but one thing I'm thinking about is what do you know about two angles that are right angles? Do you know that they're congruent? Sure. So probably what we're going to want to say is that angle ACD is congruent to angle ACB, because if two angles are right angles, then they are congruent. can always come back and change it if we need to later. Okay, so next step they said for us, oh, they already marked it for us, that AC is congruent to AC, that's reflexive. And now they're ready to say triangle ACD is congruent to triangle ACB. If I look at my picture, I think we did the right thing in step 6. We've got angle, side, angle. And that would be from steps 2, 6, and 7. Okay, what always comes after congruent triangles? CPCTC. Let's see what we need to prove though. We're trying to prove that AC is a median. So kind of like in the first one, if it's a median, we know it hits at the midpoint of the side to which it is drawn. So I'm going to want to first show that segment DC is congruent to segment CB, which I know from CPCTC. So that then in my final step, I'm ready to say that AC is a median. And this is like the first proof that we did. So we're going to say if a segment hits at the midpoint of the side to which it is drawn, then it is a median. And that's about it. So practice. Make sure that you know the definition of a median and an altitude, and practice your best you can with those long reasons. Good luck.